Assalamu alaikum wa rahmatullah. This is the first recorded lecture for the course Engineering Economics. Uh, we will start inshallah in chapter 3. راح نبدأ بchapter 3 اللي بنتكلم فيه على interest rates, that we're talking about interest rates and economic equivalence. How to deal with interest rate, what is economic equivalence, and how to do equivalence or economic equivalence calculations. كيف نعمل حسابات التكافؤ الاقتصادي وكيف نتعامل مع interest rate. Before we begin, let's review to this story. In 2005, a woman named Louise Outing, 94 years old, عمرها 94 سنة, she won the biggest prize of Massachusetts lottery. ربحت أكبر جائزة في ليا نصيب ولاية ماساتشوستس قيمتها $5.6 million. By lottery rules, the $5.6 million will be paid in over 20 years. راح تحصل على ال 5.6 مليون خلال 20 سنة. راح تاخذ دفعة أولى first payment of $283,770. راح تحصل على دفعة أولى مقدارها 283,000 and $280,000 over the remaining 19 years. طبعا عمرها 94 سنة مش حتعيش العمر كله. فتقدمت طلب للمحكمة. She went to the court that she wants to receive the amount in cash. By lottery rules, there are two options. في خيارين. Whether to receive $2.912 million in a cash value now, present today, حتاخذهم اليوم, or receiving 5.6 million over 20 years. By lottery rules, you have to choose one of the options. If you read the slip of the lottery, you will have to choose one of the options. If you choose the first option, you will get 2.912 cash value. If you didn't choose any option, then by default you will receive 5.6 million over 20 years. Long story short, she found a buyer for her price. لقت واحد بيشتري الجائزة تبعتها and he paid $2.467 million. دفع للويس اوتينج $2.46 million. ناو اعطاها الفلوس هاي, وفي المقابل هو راح ياخذ الجائزة تبعتها اللي هي 280,000 paid over 19 years. The question is, was this a good deal or not? الآن to decide if this is a good deal or not, we need to include the time value of money. He paid $200.467 million and he will receive 5.6 million. يعني إذا بنحسب بشكل بسيط 5.6 is greater than 2.467, then he made, let's say, a profit. But this is not the case. He will receive $5.6 million over 20 years or 19 years. Does it worth to wait 19 or 20 years to get 5.6 million or not? This is the question. How to deal with this? We need to introduce a new concept, is the time value of money. Money has a value because money can earn more money. This is called the earning power. If you have 100 riyals today, if you invest them, the 100 riyals will become more, maybe 200 riyals based on your investment. The second reason is that the purchasing money of power is decreasing with time due to inflation. بسبب التضخم قدرة شرائية على الفلوس قاعدة بتنزل مع الزمن. For example, if you go to 1990, if you remember that we said you can buy Toyota Corolla for 25,000 riyals. إذا معك 25,000 ريال, you can buy Toyota Corolla في 1990 in 1919. But today in 2020, if you have a 25,000 riyals, you cannot buy a Toyota Corolla. The Toyota Corolla now costs 50,000 riyals, the base model. So if you have 25,000 in 1990, you can buy a Toyota Corolla. But if you have 25,000 today, you cannot buy a Toyota Corolla. This is what we call the purchasing power of money. The purchasing power of money is decreasing over time. And as a business, you must find a balance between earning power and purchasing power. Now, how the time value or how to consider the time value or how to calculate the time value, there is something called interest rate. This is like the conversion factor between time and money. I use the interest rate to convert between time and money. And if you think of interest rate can be a cost, is like the cost of money. If I'm borrowing the money، إذا أنا قاعد بقترض المال، بروح البنك باخذ مال قرض من البنك، going to the bank and taking and borrowing money, it will be a cost on me. تكلفة علي. أنا أخذت 1000 ريال، I'm taking 1000 riyals from the bank. I have to مثلا repay the 1000 riyals, 1100 riyals. The extra 100, the interest, is a cost on me, but it is like a profit for the bank, a profit for the lender. هي ربح للبنك. هو أعطاني 1000، أخذ مقابلهم 1100، ربح مني 100 ريال. Then we come to the cash flow diagram. Cash flow diagram is a representation for the cash transactions over time. It consists of receipts, cash inflow, or disbursements, a cash outflow. Examples of cash inflows: borrowed funds, operating revenues, cost savings, salvage, working capital release. Examples of cash outflows: purchasing a new equipment, investments in working capital, manufacturing, operating and maintenance cost, interest payment, interest and repayment of borrowed funds اللي قاعد بسدد القرض تبعي, and taxes. All of them are examples on cash outflows. How to represent الcash flow? Cash flow consists of a vertical axis, which is the time axis, and we have receipts and disbursements. عندنا مدفوعات أو cash inflow. وإذا بتلاحظوا الكاش inflow دائما بنمثلها بسهم إلى الأعلى والإشارة تبعتها دائما positive. And disbursements أو cash outflow represented by a downward arrow, سهم للأسفل، والإشارة دائما تبعتها negative. لأن for convenience، لحتى نسهل على أنفسنا calculations, to make calculations easier، احنا بنعمل شيء بنسميه net cash flow diagram. إذا بتلاحظوا الفرق بينه وبين الكاش فلو السابق، إنه بدل ما كان عندي I have 5000 inflow and 500 outflow, the net is 4500. And at the last year I have 4000 in salvage and an extra 5000 minus 500, I have 8500. This form of cash flow is easier for calculations. Okay. Note that at t equals 0, and the cash flow starts at t equals 0. Anything before time equals 0, we do not consider. Usually, we do not consider it unless it's have like a financial impact. For example, can have a tax consequence, or it can be used late, or we have to account for it later on in our calculations. But usually, before t equals 0, it's called sunk cost, and usually they are irrelevant to the problem or to the financial position, unless specified otherwise. Now we will see some abbreviations that we will use for from now on in our equations and calculations. AN represents a discrete payment or receipts occurring at the end of some interest rate. For example, if I'm having a cash flow, a certain cash flow, and at T0 I'm paying some money. At T1, at tier 1, I'm receiving another money. This is 0, this is 1. In the second year I'm not receiving anything. In year 4 I'm receiving another amount of money, and in year 5 I'm receiving another amount of money. Each one of them is called AN. N represents the time. So this will be A0, this will be A1, this will be A4, and this will be A5. A comes from annuity. I is the interest rate. N is the total number of interest periods. And it's important to know that N represents interest periods, not number of years. عدد فترات اللي باخذ عليها فائدة، مش عدد السنوات. It can equal interest period can be 1 year, it can be 1 month, can be 1 day, it can be half a year. It depends on the unit of I. I is the interest rate per interest period. For example, if the interest rate is 12% per year or annual interest rate, so the interest period should be in years. If the interest rate is 1.5% for month, then N should be in month. B represents the present worth, F represents the future worth of money, A is the annuity for equal payment cash flow. If I'm having a cash flow and all the payments are equal, instead of saying A1, A2, A3, A4, just simply we name them A. And Vn is the value or equivalent value of a cash flow at a certain period of time n. If n equals 0, it will become the present value. If n is at the end of the project life, it becomes the future value. Now we have another definition, end of period convention. Usually firms or businesses report their cash flows at the end of the interest period. For example, if every business, every company usually will receive money, for example, on a daily basis or on a monthly basis, and they have to pay money on monthly basis or at any point of time in the year. Instead of saying that I paid the salaries, رواتب الموظفين دفعتهم في نهاية كل شهر, for example, at the end of each month, 30th of each month, and making an arrow at 30th of each month. And for example, if they sold something at the third month of the year, they will put it in the cash flow. Instead of doing all of these transactions during the interest period, as you can see here, we simply just sum all of them and report them at the end of interest period. Instead of saying that I have received $10 at X time, $8 at X time, $5 at X time, $12 at X time, $10 at X time, I just sum all of these transactions and put them in a single arrow at the end of the interest period. This is easier for calculations because the interest rate is paid at the end or due at the end of the interest period. إذا أنت حطيت فلوسك في البنك، استثمرتهم في البنك والبنك بعطيك عليهم فائدة، البنك حيعطيك فائدة عليهم في نهاية السنة. إذا الفلوس تبعك قعدت أقل من سنة في البنك ما راح تاخذ عليهم فائدة. If you are putting your money in a bank, the bank will give you the interest on your savings at the end of the year. If you withdraw your money before the end of the year, then you will not receive the interest. Same thing, if you are borrowing money from the bank will charge you the interest at the end of the interest period. The logic for this is makes the calculations or the equivalence calculations or financial calculations much more easier. Some conventions that usually encountered in financial analysis is year-end convention and half-year convention used for depreciation calculations. Now, how to calculate interest? We have two methods to calculate interest. We have the simple interest, charging the money or charging the interest on the principal amount. الإيكويشن F equals P في 1 plus IN. احنا بناخذ الفائدة أو الفائدة charge على رأس المال، على أصل المال. If I'm borrowing 100 riyals at interest rate 10%, then the future value for 1 year, then the future value will be 1000 ريال ضرب 1000 multiplied by 1 plus 0.1 multiplied by 1, which is going to be 1100. So there is if I'm borrowing 100 riyals for 1 year at simple interest, they will become 1100. Those extra 100 is the interest. On the other hand, we have compound interest. In compound interest, the interest is charged at the principal and at the interest. إذا أنت قرضت بنك والبنك بتعمل بالcompound interest, he will charge you interest at the principal, the 1000 riyals, and any accumulated interest in the account. And the equation is f equals p multiplied 1 plus I to the power n. This is an important note. Unless otherwise specified, all interest rates are based on the compound interest. كل الكالكوليشنز يتم احتسابها based on the compound interest. We do not use simple interest. كل التعاملات بتصير بناء على compound interest. In this course, when we deal with interest, it is always calculated based on this formula, compound interest formula. We do not use simple interest unless it is specified in the question. This is a simple example to see the difference between simple and compound interest. For example, let's see here the simple interest. I have 1,000 reals. At the first year, I will get an extra 100. It can be calculated using the simple interest equation. F equals P 1 plus IN. At the first year, it will be 1,000, 1 plus 0.1 multiplied by 1. It will be 1,100. So there is the 1,000, which is the principal, and this is the interest on the 1,000. And the second year, if we apply the equation, I will get 1,200. 1,100 is from the previous balance, and another 100, which is interest, and this interest is on the principal. At the third year, I will get 1,300. 1,200 is the balance from the previous year, and another 100, which is also interest on the 1,000 reals. On the other hand, the complex interest is a little bit different. I have a 1,000 after the first year. If we apply the equation, F equals P 1 plus I to the power n. At the first year, it will be 1,000, 1 plus 0.1 to the power 1, which is 1,100. The second year, it will be 1,000, 1 plus 0.1 to the power 2, which will be 1,210. Third year, 1,000, 1 plus 0.1 to the power 3, which will be 1,331. Now let's look at the table. I have $1,000. After 1 year, they will become 1,100. 1,000 is the principal, and 100 reals is the interest at the principal. This is for the first year. Now at the next year, my balance will become 1,210. Okay? So I will have 110%, $110 as interest. The 100 is on the principal, but the extra $10, those are interest on the interest. فائدة على الفائدة اللي هي $100. نفس الشيء ال 121 121 1,000 of them is interest on the principal, and the $21 is the interest on the interest, $210. عشان هيك الكومباوند انترست احنا بناخد فائدة على راس المال وبناخد فائدة على الفائدة. This graphical representation for our problem. Now let's see this simple example to understand the difference between complex and simple interest. Peter Minute in 1626 he bought Manhattan Island for $24 from the Red Indians, American Indians. Okay? Let's suppose that Peter Minute puts his $24 in a saving account in a bank that pays him 8% interest rate. How much would it worth in 2020? لو حط الفلوس تبعته هاي في البنك قديش راح يكون او قديش راح يصير حسابه بال 2020؟ يعني انا عندي البريزنت فاليو $24 interest rate 8% والنمبر اوف years او النمبر اوف interest periods 2020 ناقص 1626 394. وفي apply the simple interest formula F equals P for 1 plus IN. Let's just Okay, if we apply this equation, we will see that he will receive $780 after approximately 400 years. But if we calculate on using the compound interest formula, 24 multiplied by 1 plus 0.08 to the power 394, it will become this large number. This is how much money he will have in his saving account after approximately 400 years. $354 trillion. التريليون 1000 مليار. The trillion is 1000 billion. Now, to understand how this number is big, it's of course hard to know how. Just to know, Manhattan Island is one of the most expensive properties in the United States and in New York City especially. It has the headquarters of the biggest companies. It has the UN building. فالأراضي فيها غالية جدا 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 Manhattan Island. لكن most experts, real estate experts, says that the value of Manhattan Island is nowhere 354 trillion. لو بدي أشتري جزيرة مانهاتن قيمتها بعيدة جدا حتى عن 354 تريليون. So this is, even though the starting amount or the principal is only $24, but the effect of compounding this amount of money for a long period of time makes a real difference. عشان هيك كل البنوك بتتعامل بالنظام الفائدة المركبة. Now we come to the core of this chapter, the economic equivalence. What we mean by economic equivalence? Equivalence exists between cash flows that have what we say the same economic effect. إذا عندي أنا two cash flows and they have the same economic effect, I can say those two cash flows are equivalent. And notice that I'm saying equivalent, not equal. متكافئين مش متساويين, because they have the same economic effect and they can be replaced or traded for one another. ممكن, for example, if you see our example, previous example, that $1,000 compounded for 3 years, they will become $1,331. This is at n equal 0 and this is at n equal 3 years. If I look, the 1000 is not equal to the 1331. They are not equal. And this is at n equal 0 and this is at n equal 3. Even يعني حتى كمان they are different at the time basis. But with proper interest rate, which is 10%, those two cash flows are equivalent. Or those two amounts are equivalent.
To Google Maps to process requests.
Now we will see some equivalent examples. Given B, calculate F. If I have B dollars today or B reals today, how much they are going to be in the future after N period? We can calculate it using the compound interest formula. Another type of equivalence is, for example, I want to have a certain amount of money after N years. I want to have, for example, 1 million reals after 20 years. How much I have to invest today? What is B? قديش بدي احط في البنك اليوم لحتى يكون عندي بعد 20 سنة مليون ريال. Okay, let's see this example. If you want to have 3,000 reals after 5 years in saving account, that be 8% interest rate. Anyway, how much would you have to deposit now? بدي استثمر انا في حساب في البنك حيعطيني فائدة مقدارها 8% for 5 years. I want to have $3,000. How much I have to pay today? Just simply apply the equation, the interest formula equation. B equals F over 1 plus IN, or you can use this formula. B equals F 1 plus I to the power minus N. They are the same. So I will have $2,042. This means that $2,042 are equivalent to $3,000 after 5 years. Both of them are equivalent. And also, if I'm calculating the equivalency at different intervals or at different periods, I will see that 2,205 are equivalent to the 3,000. 2,381 2,381 is equivalent to 3,000, and so on. Okay, we will get to this, how to calculate it, inshallah, in the coming examples. Now, to establish the economic equivalence, there are 4 principles. The general principles for economic equivalence. The first principle, equivalence calculations made to compare alternatives require a common time basis. If I am comparing 2 different alternatives, okay, or 2 different cash flows, then I must compare them at the same time. I cannot compare alternative A at point or at n equals 0 and alternative B or cash flow B at n equal 2. Both of them should be compared at the same time or at the same time period, okay, which usually either it's the present value and we calculate what is called the present worth, or it will be the future value or future worth at the future. Either I convert the 2 cash flows, if I had 2 cash flows, different cash flows, like our example, I need to compare them at the same time. Let's see this example. We have seen the previous example that $2,042 are equivalent to 3,000 in 5 years at interest rate 8%. Thus, these 2 cash flows equivalent at year 3, at the end of year 3. So I have this first cash flow, أنا معي 2042 اليوم, and I'm expecting $3,000 in 5 years. Thus, these 2 cash flows equivalent at n equal 3 or not? To decide if they are equivalent or not, I need to compare them at the same time period. In this, يعني زي ما هم موجودين عندي 2042 at n equal 0 and 3000 at n equal 5, I cannot compare them because they have different time bases. لحتى أقدر أقارن فيهم, they should have the same time bases. Okay? So I'm choosing year 3 to compare between them. So I need to calculate $2,042 after 3 years and calculate the value of $3,000 at 3 years or before 3 years. So at the beginning I need to calculate the future value of 2042, بحاجة إني أحسب الفيوتشر فاليو ل 2042 وبحاجة إني أحسب, خلينا نحكي the present value لل 3000. How to do calculations? Either I'm using f equals p, 1 plus I to the power n. This is the future value. So v3, the value of this cash flow at the 3rd year, 2042 multiplied by 1 plus 0.08 to the power 3. Okay, this will give me $2,572. The other cash flow, let's just correct the equation. Now I'm going to the other cash flow, and this question needs to be corrected. So I'm going to calculate the value of 3000 at n equal 3. So the formula is 3000 multiplied by 1 plus I, 1 plus 0.08 to the power, see here, minus 2. Why minus 2? Because I'm jumping 2 interest periods. Here I'm jumping 3 interest periods. This is 1 interest period, 2 interest periods, 3 interest periods. So n is the number of interest periods that we use here. Okay? So we have 2 interest periods. Okay? Or in another sense, it is 5 minus 3, which is n capital minus n small. So I will get $2,572. So I can see these two amounts are equal at n equal 3. Therefore, this cash flow is equivalent to this cash flow. The second principle is equivalence depends on the interest rate. Changing the interest rate destroys the equivalence between the two cash flows. As we have seen in our example, that $3,000 are equivalent to 2,042 at interest rate 8%. What if the interest rate changes? Let's say the interest rate comes 10%. Are those two cash flows still equivalent? The 3,000 after 5 years and 2,042 present today. So let's, in example 3.3, we determined that the given interest rate of 8% per year, receiving 2,042 is equivalent to receiving $3,000 in 5 years. Is this true at interest rate of 10%? So let's calculate the future value of 2,042 at 10%. I will get 3,289. So at interest rate 10%, 2042 is not equivalent to 3,000. 2042 دولار اليوم غير مكافئة ل $3,000 بعد 5 سنين على interest rate 10%. But the equivalence is 3,289. 2042 اليوم is equivalent ل 3,289, not 3,000. The third principle, equivalence calculations may require the conversion of a multiple payment cash flows to a single cash flow. Later on in this chapter, we will get to know the different types of, or the 5 types of cash flows and how to deal with them. One of them is the multiple payment cash flow. For example, we have this multiple payment cash flow. Compute the equivalent value of the cash flow series at n equal 3 using interest rate of 10%. As you can see, this is a cash flow. This is a multiple payment cash flow. And I want to calculate the equivalent cash flow at n equal 3. How much, يعني إذا أنا جمعت هدول الكاش فلوز وحطيته في نقطة واحدة في الزمن عند n equal 3 قديش راح يكون المبلغ المكافئ لهم. If I'm adding all of these cash flows at n equal 3, what is the equivalent amount of money is going to be? ممكن, maybe the first thing comes to your mind is just summing إن نجمع 1000 زائد 80 100 plus 80 plus 120 plus 150 plus 200 plus 100. مش صح. الجمع بهاي الطريقة مش صحيح. But we do an addition, but in a different way. So how we are going to do it? We are going to move those elements in front. راح نحركهم to the, we are going to move them to the future. And those two elements, we are going to move them into the past, and the cash flow at n equal 3 will remain as it is. So how to do the calculations? V at 3, we will come to the first cash flow. The first cash flow is at n equal 0. I'm going to calculate the future value of this cash flow at n equal 3. So I'm going to use, remember the formula, F equals P 1 plus I to the power n, and B equals F 1 plus I to the power minus n. Keep those two equations in mind. So the 100 multiplied by 1 plus 0.1, and I'm going to move it 3 interest periods to the power 3, okay, plus the $80, 1 plus 0.1, and I'm going to move it 2 interest periods to the power 2. The third cash flow, or the third element, is $120, and I'm going to move it 1 interest period, okay. Now we will come to the 150. This one will not be moved to anywhere. It will stay as it is. So it is 1 plus 0.1 to the power 0. But since anything raised to the power 0 is 1, شلناها. We removed it. Now we come to the $200. This one. This one, I'm going to move it back 1 interest period. Okay, so it's going to be 200 to the power 1 plus 0.1 to the power minus 1, since I'm moving it in the backward direction, in the opposite direction, to the past, by 1 interest period. And the 100, I'm moving it 2 interest periods to the power minus 2. So if you do the calculations and do the summation, I will get $767.36. So the equivalent amount of this cash flow is 776.36. This cash flow is equivalent to this multiple payment cash flow. And we call this a compounding process, and we call this a discounting process. We will come to those two calculations, two concepts later, inshallah. The third principle is equivalence is maintained regardless of point of view. What we mean by this, for example, if I'm going to borrow the money from the bank, okay? I'm going to borrow money from the bank. This is me, and this is the bank, okay? I'm going, let's say, to borrow $1,000. So I will get 1,000. But the bank, from the point of view of the bank will pay $1,000. Okay? Now, I'm going to pay the loan that I'm taking, let's say, at interest rate, for example, 10%. And I'm going to repay the loan on 3 equal payments. Okay? So I'm paying an interest rate of 10%. So at the first year, and let's assume that I'm going to pay the interest rate. So at the first year, I'm going to pay 100 of the interest. I'm just going to pay the interest amount, which is $100. So I will have a downward cash flow. But for the bank, it will be upward. The bank now is receiving $100. Then at the second year, I'm going to pay another $100, but the bank will receive another $100. At the third year, I'm going to pay the interest plus the principal, $1,100. And for the bank, it will be $1,100. Those two cash flows are equivalent, regardless of the point of view. This cash flow is equivalent to this cash flow, regardless if I'm looking at it from the borrower point of view or the lender point of view. Those two cash flows are the same or similar or equivalent. Okay? As long as we are using the same interest rate, 10%. Those are just two examples. Try to solve them. I have two cash flows. In this example, I need to find the amount of C that makes the two cash flows equivalent. How to approach this question? Select a common point in time, let's say n equal to, find the equivalence amount of cash flow A, okay, and equate this equation equivalent to the equivalent of cash flow C and solve it. The other example is asking about the interest rate that makes the two cash flows equivalent. The same thing, use a common point in time, which is n equal 3. Find the equivalent amount of cash flow A. It will be also a function of I. Okay? And the equivalence of cash flow B, it will be also a function of I. Solve the equation for I, the unknown I, and you will get the interest rate. It needs trial and error solution. Now we come to the third part of, or second part of this chapter, is the types of cash flows. In financial التعاملات المالية, financial dealings, we deal with mainly 5 types of cash flows. نتعامل مع 5 أشكال من الكاش flow. We have the single payment cash flow, وشفنا بعض التطبيقات على هذا الكاش flow. We have equal series or uniform cash flow. We have the gradient cash flows, and we have linear gradient cash flow and geometric cash flow, and finally the irregular payment cash flow or the irregular cash flow. Those are the 5 types of cash flows اللي ممكن تمر معكم في أي مكان. Now in the remaining slides we will see how to deal with these cash flows, how to convert between those different types of cash flows. If I have a single payment cash flow, how I can convert it to, for example, equal payment cash flow, or how to convert it to a gradient, how to convert a gradient to uniform cash flow, how to convert the irregular cash flow to a single cash flow, or to convert it to equal payment cash flow. The single cash flow, we have 2 factors. One, we have a compounding process and we have a discounting process. Compounding process is having a present value and I need to calculate the future value. Discounting process, I am having a future amount of future value and I want to know the present value of this money, of this amount of money. In the compounding process, the equation is f equals p of 1 plus I to the power n. In the discounting process, p equals f multiplied by 1 plus I to the power n minus 1. And before we continue, from this point on, we will try to use the notation, this notation. It will make it easier for calculation. It will make it easier when we use something we call them interest tables. تمام؟ النوتيشن هاي يعني كيف نقرأ النوتيشن هاي أو how to read this notation. The term in brackets is calculate f given b and at interest rate I and n. What does it mean? Calculate f given b at I and n, and this factor, if you are going to calculate it, will be equal to this part of the equation, 1 plus I to the power n. راح نشوف الآن interest table. We will see the interest tables and how this factor is calculated and reported in the interest tables. Same thing for the discounting factor. Instead of writing the complete equation, we write it in the notation form f multiplied by p over f in. What does this mean? It means calculate b given f at interest rate I and n interest periods. هيك بنقراها. Calculate b given f. And determine brackets اللي موجود في الأقواس هون is the same as this part of the equation. Now we come to what we call them the interest tables. Instead of keep using the equation, for example, for single cash flow, the equation is relatively simple. But when it comes to gradient cash flows and uniform cash flows, there are too many equations and too many equations بتصير أطول شوي. عشان هيك احنا في عنا ايش احنا بنسميهم interest table. راح تلاقوهم, you will find them in the appendix in the textbook, and you will find tables, and each table is for a specified interest rate. This table is for interest rate 12%. راح تلاقوا في الكتاب from I think interest rate from 0.1% and forward, 0.1, 0.2, 1%, 2% إلى آخره. تمام? And in this interest table you will see that we have a section for single payment cash flow, we have a section for equal payment cash flow, and a section for the gradient series cash flow. For single, خلينا الآن just keep it for the single payment cash flow, we have two factors, the compounding factor and the present worth factor or discounting factor. This is 1 plus I to the power n, and this is 1 plus I to the power minus n. And we'll have the values. This is n. For example, if I want to this factor at n equal 1, it will equal to 1.12. At, for example, 5 years, it will be 1.7623. How this factor is calculated? Just apply the equation. 1 زائد 0.12 to the power 5. This is how it's calculated. And if you calculate this, you will get 1.7623. The discounting factor is calculated in the same manner. It is 1 plus 0.12 to the power minus 5. If you calculate this value, you will get 0.5674. فعشان هيك using interest table is much more easier than using the equations in some situations, and it's faster for solution, أسرع في الحل. All what I need, for example, in any example, I just need to use the appropriate factor. For example, this example, if you have $2,000 now and visit it at interest rate 10%, how much would it be in 8 years? Using the formula F equals P for 1 plus I to the power n, you will get 4,287.18. Using interest tables, بروح للانترست تيبل 10%، بطبق بجيب الفاكتور من تيبل على 10%. Okay, it will be 2.1436 multiplied by 2000 حيطلع عندي 4287. There's slight difference between those two values because I'm doing a cutoff here. I'm using it's because of the rounding of the factor. Okay, another example, I'm having $1,000 to be received in 5 years at annual interest rate of 12%. What is the interest, or what's the present value or present worth of this amount? Using the calculator or the equation, B equals F 1 plus I to the power minus n, I will have 567.43. Using the interest tables, calculate P given F at interest rate 12% and 5 years, 1000 multiplied by 0.56743, it will be 567.43. منين جبنا هالفاكتور؟ جبناه من جدول ال 12%. We have the 12% table here, we can see it here. Okay, at 5 years, this is n 5 years, and I need the discounting factor P. Calculate P given F I n, it is 5.674. So we stop here and see you inshallah in the next lecture. Assalamu alaikum.